Scientific notation. Scientific notation is a way to write very small and very large numbers in a shorter fashion. You've probably seen it. It's like the power of 10 writing. Um, in chemistry, this becomes important because we use numbers like Avogadro's number that's 6.022 times 10 to the 23rd. Well, it would take you quite a bit of space and quite a bit of time to write out the 6 and then the 23 other spaces behind it. So um, this makes it more concise and easier to manage. When you look at scientific notation, it helps to really understand what it's showing us. We know, or you may be able to look at that and go, okay, so 3.2 times 10 to the fifth is 320,000. Okay, but sometimes you some students may not really realize what this is telling you. So it's actually saying take your 3.2 and multiply it by 10 5 times. So taking that 3.2 times 10 times 10 times 10 times 10 times 10, and that will give you 320,000. Whenever you're multiplying by tens, know that you're going to be moving the decimal point to the right, so your number is going to be getting larger. Now, what if the 5 was negative? If it's negative, then that means it's a number that's smaller than 1. And so we're going to have to move the decimal point to the left. And then the number tells us how many times, 5. So whenever it's a negative, what it's telling us is that we are going to take 3.2 and we're going to divide it by 10 5 times. So we've got 3.2 divided by 10, divided by 10, divided by 10, divided by 10, and divided by 10. When you divide by 10, again, we're moving the decimal point to the left, the um, same number as the zeros. So um, you're just going to move it if, like this one, 3.2, so we're going to move it first, the decimal point in front of the 3, so that's 1. We still need 4 more places, so that's going to give us 4 zeros out in front of it. To put a number into scientific notation, you're always going to have the decimal after the first digit. For standard form, there can only be one digit in front of the decimal. And then all the zeros that are there, we don't have to write, so we can just write the number 3.2. Then we add the times 10, and we need to think, is this number that we're trying to put into scientific notation larger or smaller than 1? Since this number is larger than 1, that means our exponent is going to be positive, and we count how many times we have to move the decimal point from here to get it to where there's only one digit in front of it. So we've got 1, 2, 3, 4, 5. So we have 3.2 times 10 to the fifth. If we look at the same thing when the number is smaller than 1, we're going to do the same thing. We want one non-zero digit in front of the decimal point. Then we're going to drop all the zeros off in front of it. at our times 10, and now we have to look at our number. Is our number, our original number, smaller or larger than 1? It's smaller than 1, so it's going to have a negative exponent. And then how many times do we have to move its decimal point to get behind the first non-zero digit? 1, 2, 3, 4, 5. So we get 3.2 times 10 to the negative fifth. The rules for multiplying, we will look at how to put them into your calculator and in a way that's faster and will help save time on some standardized tests and things if you're dealing with scientific notation. But if you don't have a calculator, what's actually taking place? Whenever you're taking numbers that are in scientific notation and you're multiplying them, then the numbers themselves will just be multiplied, but the exponents are going to actually be added. So the numbers are multiplied. 3 times 2 is 6, and then you add the exponents. So this is 10 to the second and 10 to the third, so 2 plus 3 is 5. So our answer of 3 times 10 to the second multiplied by 2 times 10 to the third is 6 times 10 to the fifth. Division, you're going to divide the numbers, and then you're going to subtract the exponents. So here, if I have 3 times 10 to the second divided by 2 times 10 to the third, then we divide the numbers, 3 divided by 2, and then we subtract the exponents. So we have 1.5 times 10 to the negative first. When adding or subtracting numbers that are in scientific notation, you have to have the exponent be the same. So here, if I have 3 times 10 to the second plus 2 times 10 to the third, I need them both to have the same exponent. So I'm just going to take that times 10 to the second. I'm going to move the decimal point one more place, and so that way it's to the third. And so I have 0.3 times 10 to the third. So no, this is not in standard form right now, but to add or subtract, you have to have those exponents equal to each other. Then we can worry about getting it back into standard form. So you add or subtract your numbers. In this case, we're going to add 0.3 to 2, and then we add the times 10 to the third. If you're raising a scientific number that's in scientific notation to a power, then the number is going to be raised to the power. So if I have 2 times 10 to the third cubed, then I have to cube the 2. So 2 times 2 times 2 equals 8. And then I'm going to multiply the exponent. So 3 times 3 is 9. So then I will have 8 times 10 to the ninth is my answer when I take 2.10 to the third and cube it.